All right, guys, so I just wanted to go over a couple more things with regards to mean, range, and outliers. So you see here, I have two sets of data, okay, and we're gonna say for argument's sake that these two sets of data represent scores on a test. So let's just say, this was, say, a chapter 1 test, and then this was, say, the chapter 2 test. And we're just going to go over some of the differences between these two sets of data. I've mentioned before, when you're talking about sets of data, it's probably a good idea before you start doing anything to arrange them in order from biggest or from smallest to biggest. So if I'm looking at this first set, I have a 77, a 78. I'm just going to start arranging these in order. Okay. Looks like the next one's an 80. All right, then I got an 83, 84, 86, 87, 88. Okay. And then I got a 90, a 91, and a 95. And in that second set of data, the smallest number I have is a 12. Okay, working my way up, I got some numbers in the 60s. I got a 63, a 64, a 65, a 66, 63, 64, 65, 66. I got a 68. Okay, I got a pair of 71s, 71, 71, 72, 73, and then I have a 99. Okay, so some differences between our sets of data besides the obvious. Okay, it looks like on our chapter 1 test, okay, this class did a little bit better. Chapter 2 test, the grades are a little bit lower, so obviously they didn't do so well. Okay, but I want to talk now about outliers. Okay, and what you're looking for when you look at for outliers. So we're talking about test grades here. So if I was to talk about the range, okay, so we're going to talk about the range and how it affects outliers. If we look at chapter 1, my range is from 77 to 95. So my range there is 95 minus 77, which is 18. So 18 points separated the highest grade from the lowest grade. Okay, on the bottom, the lowest grade was a 12 and the highest grade was a 99. So my range there would be 99 minus 12, okay, which is 87. So the range of the top is 18 and the range on the bottom is 87. Okay, so you can see the big difference in the range. Okay, 18 as far as grades are concerned, that's not a very big range. Everybody was kind of packed in tight. Whereas on the bottom, okay, we had a big range all the way from 99 to 12, which gave us an 87. But that's a little range for that second set of data, that chapter 2 set doesn't really tell the true story. Okay, and this is where we get into outliers. Okay, and how outliers affect the data. Okay, I already explained what an outlier is. An outlier is a piece of data. It's kind of like the one that doesn't belong. Well, in that chapter 2 set of data, that second set of data we have there, we have two outliers. 12 is an outlier. You could also consider 99 an outlier. Because if you look at the grades, it looks like most of these grades are within this 63 to 73 range, which is only a difference of 10. So the range in that middle pack of numbers is 10. And then you got one person that did really, really well on the test. They got a 99. And then you got one person that did really, really poorly on the test. They got a 12. So what those outliers are going to do is they're going to affect the mean. So when we talk about the mean of this first set of data, since that's a nice, neat, packed set of data, the mean should be somewhere around in the range of those numbers in the middle. Should be somewhere in the middle. Should be somewhere around 84, 85, 86, 87, because that's a nice, neat, packed set of data. Whereas that second set of data, okay, it's also probably going to be somewhere in the middle, okay, but for different reasons than the first set of data. Okay, that first set of data, if I added up all those numbers, and I did this ahead of time, okay, so don't think I'm doing this in my head. If I add up all those numbers, it's 939. You would divide that by 11 for an average of 85.4, which would fit right in there, which is pretty much right smack in the middle. Okay, for that second set of data, okay, that mean is going to be 724 divided by 11, which is 65.8, which is also close to the middle, but for a different reason. Okay, these two outliers, okay, are stretching the data both ways, so they almost kind of cancel each other out. If you were to take away one of those two outliers, let's say this person did not get a 12, and instead they also got a 63. Now your average is going to be pulled up a little bit because this one person that got the 99 is kind of making the class look a little bit better than they actually are. Okay, most people got somewhere between a 63 and a 73. That 99 is going to pull that mean up a little bit. So instead of being 65.8, it might be somewhere in the low 70s. Okay, so it's going to drag it up. Now, if I did the reverse, okay, and I took away that, let's say instead of taking away the 12, I took away the 99, okay, and let's say that person got, say, a 74. Now that outlier, that 12, that outlier is doing the exact opposite. It's going to drag the mean down, and it's going to make it seem like the class actually did worse. Okay, because that one person that had the really bad day that had the 12 is going to drag that mean down a little bit. Okay, so when we talk about the mean representing the data well, it depends on A, does it have any outliers? In the first set of data, chapter 1, there were no outliers. Everything was packed in tight. So the average, the mean, is going to be a good representation of the data. If it does have outliers, how many are there? Is there one on each side? So is it being stretched in two directions? If that's the case, like this chapter 2 data, then the mean is probably going to work. If it's being stretched in one direction or another, then the mean is not going to be a very good representation of the data, because that one really high score or that one really low score, they're going to drag the mean up or down.